little bit in pre-cal. They are the functions that undo the trig functions, right? A little bit of notation here. Arc sine and sine inverse are equivalent notation. Some textbooks use arc sine. Some textbooks will use sine to the -1 here, meaning the inverse of sine. I feel like on the AP exam more recently, they've been using the inverse sine notation, but from what I understand, like arc sine's not off the table. You should know that those are the same right there. So I'm going to use both. Our textbook uses the arc sine, arc cosine, arc tangent there. But arc sine just means the same as the inverse sine there. Here, inverse trig is used to find angles. So, for example, if you're finding arc sine of 1, you are finding where on the unit circle does sine equal 1. So, like, if I am doing arc sine of 1, where on this unit circle would my sine, which is my y coordinates, be 1? It's going to be right up here. Right there's my coordinates, 0, 1. So arc sine of 1 would equal pi over 2. Or technically, at any increment of pi over 2, it's like pi over 2 plus 2 pi k. There, we won't really have to worry about that any for the problems that we'll be doing here. We're not going to have, usually if it's a problem where we're like actually plugging in a number, then domain will usually be restricted. A lot of these problems we won't even be plugging in a number, so it won't be necessary for us to do. Okay. So that's just notation right there. I am going for one of these to show you where it comes from, because I think it is neat to know. So this is sort of like we did yesterday, like proving that it has to be this way. And then you can just say, okay, I get it, and memorize the formulas. Except for on the test, you don't really have to memorize the formulas, because I will give them to you on your note card. Right, on the AP exam, the formulas have to be memorized. So I'm going to show you where this comes from. If I have y equals arc sine of x, I do not know how to find the derivative of arc sine of x. But I do know how to find the derivative of sine. Right? That's an easy one. That is cosine. Right? So, arc sine and sine are inverses of each other. So, if I wanted to, what I could do right here is I could, like, take sine of both sides of this equation. And if I do sine of arc sine, what's going to happen? They cancel each other out because they're inverses of each other. So I would have sine of y just equals x. Now, I am going to draw myself a triangle for this, okay? So, trig we use right triangles for. And what I have right now says that the sine of y equals x. Usually I like for my trig stuff to be fractions, because if you remember your SOHCAHTOA here, sine is what is opposite over hypotenuse. So this is opposite over hypotenuse, right? So if I labeled my triangle over here, I can pick either one of these angles to be y. I'm just going to call this one right here y. Y has to be an angle because you're taking sine of that angle. And so if this angle right here is y, then the opposite side over here would be x. and the hypotenuse would be y. Okay, let's just keep that triangle in mind. Okay, we're going to need it later. Because it is kind of weird that like the derivatives for these don't have any trig in them, right? Like those derivatives, when you take the derivative of arc sine, you just got letters, right? You don't have any trig anywhere. And this triangle is going to help us get there. So now I can take the derivative of this actually very easily. What's the derivative of sine of y? Cosine of y dy dx, because it has a y with it, so I got to take that derivative there. And what is the derivative of x? 1. Okay, so if I want to solve that, I just divide by cosine y, dy dx equals 1 over cosine of y. Now, that is the derivative of arc sine, but it has trig in it, right? And it also has a y in it. The formulas you have there do not. So this is how they get from here to the formulas that you're seeing, well, sort of the formulas. This is just of x. It is not of u, which could be like any expression, but it's close enough. So if I go over here, if I want to find cosine of y, that would equal the adjacent over the hypotenuse right here. Now, adjacent, I don't know what it is. What's the hypotenuse? It's 1. Reese is saying it. Did you say what I think you said? Yeah. Hunter's really on that one right now. They're doing triangles and math too right now. Too bad Rowan didn't announce it to the class so everybody could laugh at it. You haven't watched the Key and Peele sketch on hypotenuse. Yeah, substitute teacher is the best one. Okay, over here. Adjacent side. We need to find it. We don't know what it is. But I do know the Pythagorean theorem. So I'm going to just call it A for right now. Right? For adjacent. So if I do a squared plus b, not b squared, let's do a squared plus x squared. Oh, it doesn't let me erase. Make that an x. X squared equals 1 squared. If I solve that for a, I would have a squared equals 1 minus x squared. And then I would square root both sides. So a would equal the square root of 1 minus x squared. So this adjacent side right here is 1 minus x squared. So my cosine of y can also be the square root of 1 minus x squared. So that derivative is 1 over the square root of 1 minus x squared. Now, in your actual formulas, they use u's instead of just an x right here. I did not want to further complicate this problem, like this proof here, by trying to do that for you. So this would be only if you just had just an x, but this would give you the derivative. I mostly wanted to walk through this. I'm not going to expect you to be able to reproduce that, but I wanted you to see where the trig went, because it's like it just vanishes and turns into this other stuff, which is one of the things I think is so cool about math, is that like things that seem like they should not be related are, where we're taking derivatives of inverse trig, and then the trig just goes away and gets replaced with this right here, which is kind of cool to me. So if you'll look at this, 1 over the square root of 1 minus x squared, it's very similar to what you see. You got the 1 minus u squared. And instead of a 1 in the top, you've got a u prime. Okay? The reason that I've done this on all of these is because whatever you're taking the inverse trig of is not always just x. Sometimes you have 2x, or you have 15x, or you have x minus 4. So that u right there can be whatever's on the inside. And since it's whatever's on the inside, you would have to do a chain rule with that, and that's where the u prime comes from, right there. So the chain rule is already like embedded into this. You don't have to do an extra chain rule on top of it. So let's look at some problems. Okay, I've got to find the derivative of inverse sine of 2x. So, you know, the formulas are new. That derivative of sine inverse of u is u prime over the square root of 1 minus u squared, right? For this particular problem, what would the u be? 2x. So the u is going to be 2x. What would u prime be? 2. All right. So all you're really doing is plugging into this formula. That u prime is 2. And then you've got the square root of 1 minus, use some parentheses here, 2x squared. They will probably not leave that as 2x squared. They will probably do this, 2 over the square root of 1 minus 4x squared. And they'll leave it like that. They look terrible. They look scary. You want to panic whenever you see inverse trig. But with the note card, they're not that bad. You're just taking whatever that inside value is, finding u and u prime, and then plugging that into the formula. Everybody okay there? Questions? All right, let's do another one. F of x equals arctangent of 3x. Find f prime of x. So let's see if I memorize these. I'm not looking at them. I know I can't do this secretly. So if I've got arctangent or inverse tangent right there, interchangeable here, it's going to be u prime over 1 plus u squared. Is that right? On your note card, that looks good? Okay, got that one. So in this case, that inside part is just your u. What would u prime be? It's just 3. So you will have f prime of x here is going to be 3 over 1 plus 3x squared. They will probably turn that into 1 plus 9x squared. Okay? Not terrible. It's not. It's an easy one. Okay. This one is easy, or basically as easy as the last problem, but it will induce panic as soon as you look at it. Can anybody tell me how in the world this is going to end up being easy? This is limit definition of the derivative. So what are they asking us for? G prime, not pi over 2, root 3. They're asking you for G prime of root 3. Okay, so that's what it's asking you for. You don't do anything else with that except for look at it, recognize it, Oh, wait, that's the limit definition of derivative. This is asking for g prime of root 3. So, you need to find g prime of x first. Then, you will plug in your root 3. Okay? So, the formula for inverse sine, we just had it. Maybe this will help me remember it. Well, it's u prime over square root of 1 minus u squared. Okay? So, what is the u in this case? X over 2. What's the u prime? It is 1/2. Because x over 2 could really just be written like 1/2 times x. Right? So the derivative of that is just 1/2. So this is going to be a little worse than the others because we do have some fractions and stuff in here. But it's not terrible. So we want to do g prime of x first. Do not plug in that square root of 3 yet. Okay? If you try to do it now, you're going to mess things up. Just go straight derivative in terms of x. So u prime is 1/2. I'm actually not going to, well, I mean, it doesn't matter. You can square the top, square the bottom on this one. It really doesn't matter. Pretty much, since it's the only thing in the top, so we could do that too if we want to. Because, like, dividing fractions is easy as pie. So it'd be like 1/2 times 1 over the square root of 1 minus, I'm going to make that x squared over 4, like that. Ignore that line that I drew because I was going to do something else. So we could if we wanted to. You don't have to in that case, but it's probably not a bad idea for us to do that so that, because like maybe they don't ask us to plug in root 3 and we would need to know what's going on there. All right, so you don't have to simplify it like that, but I kind of like it. It makes the next steps a little bit easier too. So now we want g prime of the square root of 3, which means we'll have 1 over 2 square root 1 minus the square root of 3 squared over 4. What's the square root of 3 squared? 3. So we got 2 square root of 1 minus 3/4. That is going to be 1 over 2 square root of 1/4. What's the square root of 1/4? What do you feel like it maybe should be? Not 1/16, 1/2. Square root top, square root bottom. Square root of 1 is 1. Square root of 4 is 2. There. And so we actually just end up with 1 as our answer. There. On a free response question, you don't have to simplify. If it shows up on a multiple choice, you would have to, they'll have 1 as your answer choice. So it's a little uglier. It's definitely got more simplification, but it's really just the same process over again. All right. Let's look at one that's a implicit differentiation. Okay. So this has a this one has an x and a y in the equation that's implicitly defined. So for this one, we want to take our derivative with respect to x. Anytime we take a derivative of something with a y, we will have to put a dy dx with it. So for arc cosine of 3x. Arc cosine, that's the one that's almost like sine, right? It's just negative, I believe. So let's see if I got this one. If we're taking the inverse derivative of the inverse cosine, we should get negative u prime over the square root of 1 minus u squared. Is that right? Okay. So for this part, u would be 3x. U prime is just 3. So when I take the derivative over here, I will get negative 3 over the square root of 1 minus 3x squared. And that has an x in it, so you don't need like a dy dx there. They probably will. Yeah, I think I will on the next step. And if you want to go ahead and do it on that step, it's fine. I just don't want to lose anybody on what I'm doing there. What's the derivative of natural log of y? 1 over y times dy dx. Okay, so I need to solve for that dy dx. I need to get it by itself to get the answer to this problem. I need to divide by 1 over y, but I don't like dividing fractions. Dividing fractions is easy as pie. Flip the second and multiply. So another option whenever you have to divide by a fraction is to just flip it and multiply, right? So if I do this right here, if I do like multiply here by y over 1 and here by y over 1, this right here, that'll cancel out, right? And so then I will have, I'm going to put that y and that negative 3 together, so I'll have negative 3y over the square root of, I'm going to make this 1 minus 9x squared, and that will equal dy dx. And a lot of times with that implicit differentiation, you end up with an x and a y in your answer. So this is fine. This is what we'll have. So it is just adding like one more complication that can happen with implicit differentiation, right? It's the same process as what we've done, just adding that one more thing to it. All right, we got one more to do. This will be our worst one. And I think I shall have you try this one on your own. Okay, the inverse trig part of it's easy, right? Because the inverse trig part of it, there's arc sine of x. That should be a very easy inverse trig right there. That's not hard. You do it separately from this stuff. What do you have to do right here? What? You want to make it a fraction. So like it'll be y equals arc sine x plus, and then you got x, 1 minus x squared to the 1/2. And when you take that derivative, what rule do you have to use over here? Chain is not wrong, but you also need product. It's a product rule with a chain rule inside of it. Because you got x times this other stuff over here. So, Reese, if you and Jericho combine your ideas together, then you are correct. You got this piece and this piece right here, but you got like the inside part of this piece right there. So it's a product with a chain. The inverse trig is actually the easiest part of this right here. So try this one on your own. I'm gonna freeze my screen and work it out as well up here. We don't actually go because today is the day that we don't have EHS. Right? Yeah, there's like a business advisory meeting, and so they for it just comes we got an extra 2 minutes to do your work. Unless, I mean, I know a couple of you like leave or have like to go do online classes. So I'm assuming if you normally have to do that, then you do go ahead and do that. You are going to take the derivative of arc sine. You should get 1 over the square root of 1 minus x squared. Here, it is a product rule. X times 1/2, 1 minus x squared to negative 1/2 times negative 2x, because you got to multiply by the derivative of the inside there, plus 1 minus x squared to the 1/2 times 1. And so if you put this, and this together, you'll get a negative x squared times 1 minus x squared to the negative 1/2 plus 1 minus x squared to the 1/2. At this point, some of you guys were factoring out a 1 minus x squared to the negative 1/2 because you kind of did like this section right here separately from the other part. That works beautifully. I just didn't do it that way. So you'll end up with the same answer at the end if you do that. What I did here is I sent this back down to the bottom of the fraction because I realized that it was the same as what I have here. All right? When you send this back down to the bottom, you're going to have square root of 1 minus x squared in the bottom. And then this one, I changed it to 1 minus square root of 1 minus x squared. And I'm so close to having common denominators for everything here. So I multiplied my last fraction by the square root of 1 minus x squared over the square root of 1 minus x squared. And when you do that, all of your denominators are the same, so you can combine them. So you got 1 minus x squared, and then when you multiply the square root of x squared, or 1 minus x squared, times the square root of 1 minus x squared, you're just squaring a square root, and you get 1 minus x squared right here. And if you combine those, 1 plus 1 is 2, and negative x squared minus x squared is 2x squared. And I stopped here because if you got all the way to the answer, I was going to be really impressed. Connor did get all the way to the answer. We're going to see if you did it right. We're going to see if he can tell us the good logic. Y'all get all the way to the answer?
We got all the way to the bottom like that, 2 minus 2x.
You got that far? Yeah.
That far.
Okay. D is actually the right answer, which is the one you would not have guessed because it's too different from the rest of the questions. All right, how do we do it? What do we do from here? 2 comes out of the top. Oh, there's a 1 minus x squared. That's to the first power, right?
And then you divide everything by 1 minus x squared.
Yeah, you could do it that way too. And then this, you could just subtract those 2, 1 minus x squared to the 1/2 power, which is 2 square root of 1 minus x squared, which is D. So D is the answer for that one. Now, that one is pretty